Example 14, our last example. So cells A and B and center 0 galvanometer G here is connected to a uniform wire OS. Okay, so it is by using joki X and Y. So sekarang ni dia ada dua joki. So the length of the uniform wire is 1 meter and its resistance is 12 ohm. Okay, so what do we have? We have the length of the wire, which is equal to 1 meter. And then we have the resistance of the wire, which is 12 ohm. Okay, so when the length of OY is 75 centimeter, the galvanometer does not show any deflection when OX is equal to 50 centimeter. Maksudnya G is equal to 0 lah at that point. Okay, and then if Y touches the NS of the wire, OX will be equal to 62.5 centimeter. So the galvanometer is balanced. So the EMF of the cell B is 1 volt. Okay, so we have to calculate the following. So firstly, let me extract the information. So we have the EMF B, which is given as 1 volt. Okay, so dia cakap G is equal to 0 when LOY untuk the first current to be equal to 0.75 meter. Kita tengok the first situation dulu, okay? And then the length OX1 pula, dia equal to 50 centimeter, which is 0.5 meter lah, okay? So this one, kita draw dulu dia punya current direction. Ini untuk the first situation, which is this one, okay? So this is gonna be equal to, this is the current punya movement. Okay. Up till here je. Then this in. Okay, I'll label it as I1 lah. Okay, I1, I1, I1. This is untuk situation yang ini. Okay, untuk situation yang ini. Okay, so dia punya distance is given as 0.75 meter. Okay, this is LOX untuk current 1. And then OY pula. What else given? Length of OX dengan OY. OX. Betul lah. This is OX1, which is equal to 0.5 meter. And then we have yang Y di sini, which is LOY untuk the first situation. Okay? Okay. So again, remember, we are going to use potential divider in this subtopic. Okay? So since wire OS here is uniform, we can use the ratio of R and the length. Okay? So firstly, we are going to look at the resistance for OX1 divided by the total resistance of the wire, which is ROS. Okay, resistance of the wire. Then equal dengan the length. So resistance of OX1 mestilah kita akan consider length of OX1 juga. Okay, so this is again over the length of the whole wire. So all LOS lah. Okay, boleh. So dari sini kita boleh cari resistance of OX1, which is equal to 6 ohm. Okay, ini untuk resistance from point O until point X. Okay, next kita do the same thing tapi untuk ROY. Untuk ROY, so ROY1 ROS equal to LOY1 over LOS. Okay, so ini ratio. Okay, kita guna potential divider, which is the concept is about ratio lah, the ratio. Okay, so you should get 9 ohm. Okay, so after kita dapat the resistance, we can then calculate the current, okay, which is I1. Okay, remember G is equal to 0, baru kita boleh state that the volt from point OX is equal to the EMF at point B. Okay, and then from here we get that VOX1 is also equal to I1 ROX1. Okay, so dari sini kita just substitute I ROX1 to be equal to EMF at point EMF B lah. Okay, so dari sini kita dapat sudah I1 is equal to 0.17 ampere. Sebab kita ada value EMF B, kita ada value of resistance from point OX. Okay? Okay. After that, kita akan tengok bila this jockey is now at point S. Okay? Sekarang ni, the jockey is at point S. Okay, let me just redraw that. So, we have gitu. And then gitu. Okay, just skip this part if it's too slow. Okay, so we have G here. And then this one, oops, sorry. This one is gonna be at point S. Yang second situation dia tulis tu ah. Sorry. Okay, and then this one is gonna be around here lah, macam tu. Okay, so the jockey for jockey Y is gonna be at point S sudah. Dia pindah at the second situation. Ada dia tuliskan dalam tu soalan, dia cakap if Y touches the end S of the wire, OX becomes 62.5 cm. Okay, ini untuk that situation. Alright, so this is EMF A, this is EMF B. Okay, so dari sini kita akan dapat this link is LOX untuk current yang kedua. Okay, kita label as number 2. Oh, salah lukis. Okay, it's gonna be like this. Sorry, I don't think you can see that. I'm just gonna use black lah. Okay, so this is the current up until here, and then it goes back up here. Okay, so this is our I2. Okay, alright. Now, kita akan buat the same thing, which is using the ratio lah. But firstly, let me just write LOX2 is now equal to 0.625 meter. Okay, and then sekarang LOY pula, it is equal to 1 meter lah, sebab dia sudah touch point S. Okay, wait, so this is 0.0 lah. Alright, okay, now again we will be using the ratio. So we are looking for the resistance for wire O until X. Okay, so ROX is over the whole wire punya resistance equal to the length OX and then the length of the whole wire. Okay, so dari sini kamu should get the value of 7.5 ohm. Then do the same thing untuk ROY lah. Okay, ROY. So this is ROS equal to LOY divided by length of the whole wire. So ini you should get equal to 12 ohm. Okay, untuk the length of OY tu sudah misterius lah 1. Okay, so kamu akan dapat 12 ohm. Alright. Okay, so dari situ kita sudah dapat jawapan. Oh, okay. I'm sorry, I forgot. Okay. So the potential difference across OY when OY is equal to 75 centimeters. So untuk this situation, I actually didn't answer the question. So dari sini kita patut jawab terus ditulis VOY1 is equal to I1 ROY1. So it's gonna be equal to 1.53 volt lah. Okay, so what are we doing is we are trying to find the value of the current. Baru kita boleh cari the voltage across point O to Y. Okay, so kita dapat 1.53 volt lah. Okay, lepas tu untuk this one we are still gonna find I2 lah. So kita buat balik. So VOX2 will be equal to the epsilon B. Okay, remember, bila G here is equal to 0, this voltage here will be equal to the EMF below here. Okay, so this one do the same thing. So VOX2 is also equal to I2 ROX2. So you should get substitute di sini dulu lah. Okay, so you should get I2 to be equal to 0.13 ampere. Okay, so dari sini kita substitute dalam ini untuk dapat, so kita guna VOY2 equal to I2 ROY2. So you'll get 1.56 volt. Okay, so this is question B. This one here is question A. Okay, boleh faham ka? It's okay. You'll understand it more when you start doing the exercises. For this one, if you need help with the exercises, I can help you lah untuk potentiometer je. Alright. Okay, so question C pula. Internal resistance of cell A. So that one is just using EMF A equal to I R plus R. Okay. So this one we do not have the value of epsilon A. So we are gonna do it using the one we've calculated lah. Okay, so the R is kita guna untuk ROY1 lah, which is this one. Okay, untuk dari OY ni kita guna until OY. Okay, boleh faham ah? So now we'll then get equal to 0.179 plus R. So this is our first equation. Okay, and then we are gonna use the second one, so which is I2 ROY2 plus small r. Okay, so dari sini epsilon A equal to 0.1312 plus R, which is our equation 2. So we can equate these two equations. So you should get R to be equal to 0.65 ohm. Okay, and then lastly, EMF of cell A is EA I 1 R plus R. Okay, ROY1 na kita guna. Okay, so dapat lah 1.64 volt. Okay, right. So that is the solution for example 14. So basically for this one, you just need to be able to use the concept of ratio. Okay, the concept of ratio R over L. R against L. Macam tu lah. Okay, so if you are able to use the concept of potential divider in this question, you shouldn't have any problem with it. So basically why I label I1 and I2 is because there is two different situations. Firstly is when OY is equal 75 cm. That's why kita buat macam ni. Okay, and then after that, kita label I2 balik. Just to not be confused with the first one here. Okay, so that's why kita kira macam tu. Itu when S2 sudah berada di joki Y is already at point S lah. Alright, okay, so if you do have any problem with this, feel free to ask me to explain it further to you lah, face to face pun boleh. Right, okay, so that is on example